This film number 5 on different industrial protocols is about Profibus and Profinet actually. And the organization called PI used to be Profibus International, now it's Profinet International. They are responsible for 3 different protocols: Profibus DP, Profibus PA and Profinet. And here is a link to their site. And the Profibus DP and PA, they are the older protocols, while Profinet is the modern based on TCP/IP. This is for decentralized peripherals. This is for process automation. This has focus on being fast and reliable. This has focused on safety. So let's talk about Profibus DP and Profibus PA first of all. Profibus DP is for factory automation, while Profibus PA is for process automation. So you can imagine you have a network here which is to the DP, the fast DP network here, used to turn on and off valves and so on, while Profibus PA is for process automation, which is usually in hazardous areas or where timing is critical. So therefore you have this safe network here. In every Profibus PA network you will find a Profibus DP as a backbone network. And this here could, for example, be a PLC communicating with the devices here in a Profibus DP network. So it's designed for fast networks and safe networks. And then you have this here, the green here is the Ethernet based network. So here's the difference between what goes on in such networks. Here in the process automation, heating, cooling, mixing, stirring, separating, and doing analysis on chemical and physical properties. So this is what goes on in a tank, for example, while this is what goes on in a conveyor belt. So here are different focus areas for the 2 different networks. If we look at this in the OSI-Model, you also have a third one, the FMS, which is basically obsolete. So DP and PA, they are both defined in layer 1 and 2, where you for DP basically use RS485. PA use something called IEC interface, IEC 1158-2. The mid layers here, same as Modbus, the mid layers are basically not used. And then you have here on top here, above the OSI-Model, you have the functions. So this is the program that runs on the PLC, which has all these functions, very much like the ones you saw in Modbus. The link between the DP and PA networks in this figure here, that would be the blue box here. That's the link. That is actually a gateway, because you have 2 different networks. You have a DP, fast DP here, and safe PA network here, and they operate with different protocols, so you need a protocol translator. The gateway here comes in 2 different forms. If it's a couple, then it's simply a signal transformer. So that's a simple version, and that means that the slow communication here makes this network here being equally slow, while a link is able to buffer data, so you can receive fast information to the link, and the link will distribute the data here in a slower format, but it buffers data in order to get it through to the other side. So the link is more advanced, a bit more expensive than the coupler. Profibus works in a master-slave manner. You have one PLC, it communicates to the different slaves in this setup here, and it's the only one that initiates communication. So it can send a message to this slave, this one will reply, then another message to this slave, it will reply, and then this slave, and then this slave, and so on. Request, reply, request, reply. But in some cases, you may have two PLCs. And the two PLCs may, for example, require data from the same sensor. So you want to have two PLCs like this, and maybe even a programming PC or a fault-finding PC or whatever. And you want to access the same equipment. So this PLC could also be interested in the data from this, if this was a flow sensor, for example. Well, to make that work, you may have multiple masters in a network, but only one at a time. So between the masters, there is a special message, a token, like a relay stick, that goes between the different masters in the network. And if there is only one master, like in this case, that token just goes from the master back to the master itself again. So while that is going on, you may attach another master and it will discover it and start to send the token around in a ring-like manner like this. Now, only the PLC or only the master that holds the token, that holds the relay stick, is able to communicate with slaves. So in that manner, you still have reliable, safe communication without chaos on the network. The addressing is usually very simple. Like in this case, the address here is 03, and is simply done by hardware. When the programmer writes a program for the PLC, he sits on his own PC. So you sit on a laptop or something, write the program, and then when the program is ready, you dump it over to the PLC, and the PLC starts running the program and communicate via, for example, Profibus to the other devices here. There is something called GSD files, which is downloadable from the internet, which is very much like drivers in a Windows world. So you got a GSD file for this device, and this device, which you download from the internet onto your computer. So when you write the program, the program itself knows how these different devices behave. So the GSD file is German for Gerätstammdateien, but it's basically the setup of a device.